Okay, so here we are back at the beginning of the data analysis module. I had thought I had all of the data analysis module recorded and uploaded to the YouTube channel, but I've realised that the first sort of 2 chapters of work were pre-COVID and I hadn't actually recorded the beginning of data analysis when we went to online learning. So I'm just filling that gap here. So there's videos covering, if we're talking about the Cambridge textbook, the first 2 chapters worth of data analysis. I'll be recording those now. The remainder of data analysis is already available to you on the YouTube channel. The first 2 chapters cover univariate data, so where you are dealing with a single unicycle, one wheel, univariate, one variable. We're dealing with one variable in our data set. From sort of chapter 3 onwards, so the last 4 chapters of the data analysis works with bivariate data, so where we're dealing with 2 variables, bicycle, 2 wheels, bivariate, 2 variables, and we look at scatter plots and things like that. So let's go back to the beginning here and look at univariate data, and before we even do that, we want to talk about types of data. So there are slightly different names for these depending on where in the world you are, but if you are here in Australia, in Victoria, doing the VCE, these will be the words you'll need to use to describe the type of data. So essentially, we have data, might be, words, numbers, symbols, yes, no, whatever, okay? A whole list of data, and data can be divided into 2 main categories, numerical data and categorical data. So that seems a fairly obvious distinction. Numerical data, the data has a numeric value, but you should be a bit cautious about that because sometimes categorical data might also have numeric value. But the point is actually that it's not just about it being a number, it's actually that it has numeric value. Okay, so that number means something. 3 is bigger than 2 and there's meaning in that. It makes sense to, do calculations with the numbers. I'll talk about examples where, that's not the case in a little bit. The other kind is categorical data, so essentially, really, if it's not numerical, it's categorical. And obviously the data needs to be able to be divided into 2 or more different categories, whether that's just simply, gender, whether that's eye colour, whether that's hair colour, whether that's city of birth, whatever it might be. They would be examples of categories. Then within each of those 2 types of data, numerical data versus categorical data, all data can then be divided into 2 further types. So we end up essentially with 4 different data types that you're going to need to be able to identify. Numerical discrete data, numerical continuous data, categorical nominal data, categorical ordinal data. Okay, so in the numerical section, discrete data, generally speaking, you're talking about variables where you're looking at a countable quantity. So the number of something is usually a discrete variable. Technically, usually the data can only take certain values. So for example, whole number values. So when we talk about, the example I've got listed here is the number of people in a household. A household can't have 3.7 people in it. It either has 1 or 2 or 3 or 4 or 5 or, perhaps up to 10 or more. I don't know what the maximum number is. But the point is that it can't be somewhere between 3 and 4 people. It's either 3 people or 4 people. Those are 2 discrete, separate numbers. I think I'll talk about when we talk about continuous, but I think generally it's best to think about, people sometimes get bogged down in, but my height, if it's height to the nearest centimetre, then it can only be 170 centimetres or 171 centimetres. But that's purely just a rounding thing in terms of how you've chosen to record the data. It's not that the value can't actually take something in between those 2 values. Generally speaking, as I said, it's usually when you're talking about the number of something. The number of red cars I observed on the road today, the number of people in a household, the number of times I rolled a 6, etc. Continuous numerical data, on the other hand, is not restricted to any particular value, and it's usually a measurable quantity. So I usually make the distinction, it's usually discrete is countable things, the number of somethings I have. Continuous is measurable things, time, distance, weight. And essentially the level of accuracy of your measurement is only limited by the instrument that you're using. So if you've got a set of scales that only measure your weight to the nearest kilogram, then you're going to get weight data that is all whole number of kilograms. But it's not a whole number of kilograms because the data is discrete. It's a whole number of kilograms because your measuring implement, your scales, only give you the information in that form. It doesn't mean, if you stand on the scales and your weight is 75 kilograms, it doesn't mean that you exactly weigh 75 kilograms. It means that you weigh somewhere between 74.6 and 70, 74.6 and 75.4, for example. And we can continue to narrow it down. So we're only limited by the accuracy of our measuring implement. So even though we might give the value as a whole number, it is still a continuous variable. Categorical data can be divided into either nominal categorical data or ordinal categorical data. It's probably easiest to talk about ordinal first because essentially I'd be trying to decide, is this ordinal, and if it's not, then it would be nominal. So ordinal categorical data is where there is an implied order or hierarchy in the categories. Okay, so for example, education level, high school, diploma, degree, there's an implied order to those categories. A survey where you might be asked to rate your opinion on a scale from strongly disagree to strongly agree. They would be categories: strongly disagree, somewhat disagree, neutral, somewhat agree, strongly agree. You've got 5 categories there, but there's order to those categories. You wouldn't, if you were doing a histogram or a bar chart or something with this data, you wouldn't randomly mix up the order of those bars. Okay, you would put them in a particular order. Whether you went from strongly agree to strongly disagree or strongly disagree to strongly agree, that doesn't matter, but there would be an order within that. Whereas if we were talking about the example I've given in nominal categorical data would be eye colour, for example, blue, brown, green, grey, hazel. There's no prescribed order in that. This isn't about you placing value on it. It's not about you trying to say, well, that thing's more important or that thing's better or more people have that thing, hence it's the number one thing. It's not about that. It's just about whether the categories themselves have implied order. So as I said, a good way to think about it is if you were to draw the categories on the horizontal scale on a bar chart, if you were to think about what order you're going to arrange your bars on your bar chart, if there's no clear order that those bars should be arranged, then it's going to be nominal. However, if it makes sense to go from, as I said, strongly agree to strongly disagree, or from, high school level education up to master's degree education or doctorate, or if it makes sense to go from, I don't want to give a confusing example right now, but whatever something that might have order, then that's how you want to think about it. So is there order? It's ordinal categorical data. Is there order implied in the categories? Not am I placing a value judgment on on the fact that I think there's an order here, but is there implied order in the categories, or isn't there? In which case, then you've got nominal data. There's no implied order or hierarchy. Okay, so a couple of things to note, and then we'll have a quick look at some examples. You must carefully consider the data being collected. So sometimes you might be talking about the same variable, but they might be different data types depending on what's actually being collected. So for example, if you were recording participants' height in centimetres, that's a continuous numerical variable. Whatever level of rounding you decide to choose, it's a continuous numerical variable. But if you were to ask participants to classify their height as short, average, or tall, then that's an ordinal categorical variable. So the variable is still height, but depending on how that data is being recorded, that defines what kind of data type it is. So you do need to know that information as well. Obviously, if you were just asked about height, you would assume it's being given as a measurement, but the point is that you do need to know what's actually being recorded to be able to be clear about what the data type is. The other thing I touched on before is that numbers don't always mean numerical data. So, for example, we use numbers for things like phone numbers and postcodes and house numbers and shoe sizes. And really, in this case, they're just being used as convenient ways to categorize things or to name things. Essentially, now shoe size is a slightly ambiguous one, but essentially, the way I like to think about it is, if it doesn't make sense to average the data, to do some sort of mathematical calculation with the data, then it's probably not numerical data, even if we could. So for example, postcodes, if you wrote down a list of people's postcodes, it would make absolutely no, it would be a completely meaningless measure of that data for you to add all those numbers up and divide them by however many numbers there are to work out the average. The average postcode is useless, doesn't tell us anything. Similarly with phone number. Similarly with the house number at which you live, you know. I live at number 10, I live at number 15, or I live at number 35, I live at number 464. If we were to average all those, that's a useless, meaningless measure. Shoe size is probably slightly different, and I think it's one of those bit ambiguous ones that you could argue it in different cases. You could possibly argue it is a discrete numerical variable. And also it depends, again, it depends on how the data is recorded. So for example, European shoe sizes, where, you know, your foot size might be, you know, 40, 41, 42, 43, whatever, that's actually connected to a measurement of the foot. I'm not sure what unit, in what units, and where, you know, I think it's the length of the foot in, anyway, I'm not sure what the measurement is, but it's actually connected to a measurement. So therefore, you could probably argue that's perhaps a numerical variable, and maybe even continuous. So perhaps I shouldn't have listed shoe size there. I think that's a slightly ambiguous one. I want you to sort of rest assured, whilst, you know, there will be times that the VCEE do want to test your understanding of this, and they have been known in the past to throw out some ambiguous ones which have turned out to be quite controversial in the aftermath of discussions of the exam. But essentially, you know, please try to take confidence in the fact that they're not setting out to trick you, so it's not going to be something completely ridiculous. But it is quite possible for there to be data that is numbers, but that is not numerical data. That's the key thing I want you to be a bit mindful of. Okay, so, alright, so below, sorry, I can ignore that header, I should have edited that. So here we've got a whole list of data variables. Let's classify them as being discrete numerical, discrete, numerical continuous, categorical ordinal, or categorical nominal. So the first one is height in centimetres correct to the nearest centimetre. So this is definitely going to be a numerical variable. It's a measurable quantity. Okay, we're rounding to a whole number, but that doesn't matter. It's still going to be a continuous numerical variable. Shoe size, I'm going to cross that one out because I think there's a lot of ambiguity there, particularly depending on, as I said, European shoe sizes might be arguably more like a measurement, whereas US and Australian shoe sizes, it is more an arbitrary, people that have, you know, feet between this length and this length are a 9, you know. Hand span in centimetres correct to 1 decimal place. Okay, we're measuring to 1 decimal place here, but it's still going to be a continuous numerical variable, so it's exactly the same as the, continuous numerical. It's exactly the same as the height in centimetres. Age in months. So in months, it's time. Again, it's a bit like, well, we're rounding to the nearest month, but it's still a continuous variable. It's time, it's a measurable quantity. So I would again say continuous numerical here. Oops, continuous numerical. As I said, sometimes, you know, you can get into quite robust discussions around some of these, and as I said, that happened a few years ago with an exam question that was set where the VCEE expected the answer to be such, but then there was a whole lot of discussion afterwards about, you know, actually we don't really agree with that. So, you know, there are examples which could be argued to be in more than one category. Birth month. So January, February, March, April, May, June, July, it's going to be one of 12 words. Okay, I'd say it's definitely categorical. But I think there's an implied order in the months. You know, if I was going to draw a bar chart, I would definitely, you know, number of people born in January, February, March, I wouldn't randomly order those months. I'd put them in a particular order that we're all comfortable with, a conventional order. So I'm going to say ordinal categorical. Eye colour, we've talked about that previously, so definitely categorical, but no implied order to the eye colours, so nominal, categorical. Hair colour, same, nominal, categorical. Number of siblings, so remember I said number of, it's a countable quantity. You can't have 3.9 siblings, you either have 3 or 4 siblings, so that's going to be a discrete numerical variable. Number of pets, same, number of something. Home postcode, we've talked about this, it is numbers, but not numeric. Also, there's not an implied order in the postcodes. You know, one's not better than the other or bigger than the other based on the number. They're purely just labels for different areas. So I would say nominal. They're just nom is, there's a Latin derivative there. I'm not a Latinist, please don't, but there's a Latin derivative there from name. Essentially what nominal is indicating is it's just a name for a group of things. And that's all a postcode is, Postcode 3000 is just the name for a particular area that some council has decided the boundaries of in the middle of Melbourne. Okay, so nominal, categorical. The time you wake up on a school morning, that's time, so I'm going to go with, continuous numerical. Mode of transport for getting to school, so bus, train, walk, cycle, whatever it might be. They're definitely categories, no implied order in those, so nominal, categorical. The time taken in minutes to travel to school, so again time related, so continuous numerical. And yes, it's to the nearest whole minute, but doesn't mean that we couldn't, measure it more accurately if we used a stopwatch, for example. The house you're in at school, so again that's a category thing, okay? So there's no implied order if you're in a school with houses, which some schools might not have houses if you're not familiar with that, but essentially a way of grouping the students into teams, if you like. There's no implied order in the teams. Okay, when you have a particular competition, there might be a ranking of them, but that's related to that competition. Implied in the fact that you are placed in a particular group, there's no order in that. Yes, by all means we can alphabetize things, but that, again, that's not, the order is not implied in the particular category. We're just imposing a common ordering mechanism. If we were going to draw a bar chart, yes, I'd probably alphabetize them or use some sort of order, but that order isn't implicit in the category itself, okay? So I'm going to say nominal, categorical. The summer sport that you play at school, okay? So maybe you play cricket, maybe you play tennis, maybe you do rowing, maybe you play, I don't know, basketball in the summer, maybe you, whatever, okay? So the summer sport you play at school, they're just they're categories, again, no implied order. Nominal, categorical. Whether you have been involved in a student committee at senior school, true or false. So the data would be recorded as true or false. So those are categories. And there's no implied order in true or false. It's really just one or the other, yes or no. There's no implied order. I think it's hard to justify that there's order if you only have 2 categories, because there really are only 2 orders. You either say yes and then no, or no and then yes, but that's just because there's 2 things. There's only 2 different ways to list them. So again, I'm going to say nominal, categorical here. Favourite AFL team. Okay, so again, categories definitely, not numerical, but nominal, categorical. Favourite Harry Potter book. And the data is going to be collected using a number from 0 to 7, where 0 represents I haven't read or don't like Harry Potter books. 1 is obviously book 1, 2 is book 2, up to 7 for book 7. So the data recorded will be numerical, but those numbers represent categories. It doesn't make sense to average them. It would be meaningless to know that the average favourite book is 3.7. Okay. because that doesn't mean that most people like book 3 or book 7. That's not how an average, book 3 or book 4, so that's not how an average works. So that would be meaningless. So definitely categorical here. But I would say, given that there is a clear sequence to the books, that they are ordinal. You know, if I was going to draw a bar chart of, you know, the number of people who prefer each book, I wouldn't randomly list the books. I would list them in the order of publication, hence the order that, you know, we commonly know them. So I'm going to say ordinal categorical. I have had people argue that this one would be nominal, but I think definitely categorical, there's no doubt about that, but I think there's order in that. And amount of Vegemite you like on your toast: none, a little, a moderate amount, a lot. So you've got 1, 2, 3, 4 different categories, and again, there's implied order in that. Each one there's a bit more Vegemite being added. Okay, so again, I'm going to go with ordinal categorical for this one here. Okay, I want you to pause the video with each of these and have a think through these. So if you were collecting data at the zoo, for example, think about all the things that happen at the zoo. Give an example of each of the following variable types about which you could collect data. So think about discrete numerical, continuous numerical, nominal categorical, ordinal categorical. So let's think. So maybe have a pause, try and come up with your own things. There's, you know, infinitely many answers here. Try and come up with your own ideas. So if we were looking at maybe a discrete numerical variable at the zoo, so we're thinking about discrete numerical being countable quantities, it might be the number of visitors per day to the zoo. I have done this example before, and students say things like, you know, the number of elephants in the enclosure. Okay, but that's not something that you're going to collect data on, because that's not going to change. That's a fixed value. You're not collecting data about the number of elephants in the enclosure. There's always 3, for example, elephants in the enclosure. Okay, yeah, one might be being washed in a different enclosure, but you know, you need to define that a bit more precisely. So, you know, number of visitors per day. Each day there'll be a different number of visitors, but it will be a discrete countable value that we can record. Continuous numerical value, continuous numerical variable, sorry. So we want sort of a measurable quantity. So we want to think about things like weights and lengths and heights and times, and so we might say, you know, time spent in the butterfly house. In minutes. Nominal categorical. Okay, so no order to the categories. So this might just be animal species, for example. I'm not sure if species is the right word, I'm not a biologist, but yeah, just a list of all the different types of animals, I guess. So, you know, something along those lines. An ordinal categorical, where there is an order implied. What about maybe, I'm thinking something along the lines of, I was going to say ticket types. So, you know, child, adult, senior, family, but perhaps there's not really an order in those. Okay, yes, they get more expensive. There's perhaps not an order. All right, what about something like, you know, imagine sort of a survey, so satisfaction with visit. You know, visit was awesome, good, okay, bad, for example. So we've got 4 categories in which there is an implied order. Okay, I'm not going to record for the next 2, but I would encourage you to take some time to sort of think about these and come up with your own answers, just to sort of, you know, stretch your own memory with what each of these things mean. So if you were collecting data in a hospital, what might be discrete numerical, continuous numerical, nominal categorical and ordinal categorical things, and similarly if you were collecting data on an aeroplane or on a flight, which feels like a strange thing to talk about now, and We're not really able to fly anywhere, but at some point we'll be able to go on planes again. And what might be an example of a discrete numerical variable of something that's happening on the plane. Discrete numerical could just be, number of passengers per flight or something like that. Continuous numerical could be, the volume of fuel on each flight or something along those lines, something to do with a volume or weights of bags on a weights of bags or whatever it might be. Nominal categorical could be so an unordered category could be different meal options, vegetarian, vegan, kosher, halal, whatever. Ordinal categorical might be, again, you can always go back to a sort of survey related thing or a ranking, related thing. Level of satisfaction with today's flight, similar to what we did with the zoo or something along those lines. Anyway, so just getting familiar with those 4 different data types, you will absolutely be asked and assessed on, identifying, what data type is this, or which of these are a, ordinal categorical variable. You can certainly expect questions like that on the exam.